Hello everyone. I welcome you, sir. Hello everyone. Welcome to another session of the DataHour series. We are thrilled to be here with you this evening for a session full of action-packed learning. I am Samriddhi Chaturvedi, the moderator, and Samrat will be the chat moderator for the session. So for those of you who have joined us for the first time, a brief introduction to the session. So the DataHour series is a series of webinars conducted by Analytics Vidya and led by top industry experts. It is a fun way to understand from the leading players in the data tech domain. And as the name suggests, it's 1 hour dedicated to data. We are hopeful that these sessions are going to be a great source of enrichment and value adding to our community members. Now on to our session today, which is M in ML stands for math and magic. In this DataHour, Asapanna will teach you how a simple software engineer can do ML and produce 95% accuracy models. I hope you're excited to attend this DataHour with us. Before we kick things off, I hand it over to a speaker. I would like to have a quick recap of the rules. We are recording the session and the recording will be available on the YouTube channel. I'll be providing you with the link. Please use the Q&A for asking any questions you may have during the session. And we will be having a feedback poll towards the end. So you all are requested to kindly fill that up before leaving the session. Now on to our speaker, Asapanna Ramesh with us. He is an applied, So a brief introduction, sir, I was giving about you. So he is currently an applied research and software engineer specializing in machine learning and deep learning. And he's currently working as applied research and software engineer at GovAI and senior research and geospatial engineer at Genesis. So over to you, sir.
Hey everyone. Thank you for joining. I see 101 participants here. That's a good number and it's still increasing. It's 103 now. That's cool. Cool. Anyway, let me share my screen quickly and let's start with my presentation. And everybody can see my screen, right?
Yes, sir.
Yes. So before starting, let me introduce myself. Other than what was told about me, I myself am in this machine learning since 2018 when I founded my own startup. So I have seen things go from very little to very big in this very short span of time. So there were so many advancements that I could not even keep track of. So there were so many things. So here,
Sorry to interrupt you, sir. Can you? There's, I think, disturbance at in your voice. It is breaking. So can you please look into that?
1 minute. Let me check my internet connection. How clear am I now? How clear am I? Am I audible? Hello. Hello, am I audible? Hello.
Yes, Rakesh, you're audible, but it's not clear.
What about now? Am I audible enough? I think. Let me change my device. 1 minute. Hello, hello. Am I audible now? How clear am I now? How clear am I now? Hello, hello.
You are audible, but the voice is not clear.
Okay, I think it's somewhere around. I have 1 Mbps with me right now, and even my devices are. Everything is fine from my side, I hope. But
It's better now, sir. I think we can continue.
okay. Uh, Let me start by saying I have seen since 2018, I have been in this field and I have seen people use many technologies under the hood to build models. And one of them is Keras, which is favored by many people. It keeps, please raise. So Vaishnavi raised hand. Did she mean anything? Chat notes. Okay, okay. So here, what I have seen is people use different technology stacks to build models. Some use Keras. Keras is built around TensorFlow, and then even TensorFlow had its own version called Swift for TensorFlow. And even after that, we have PyTorch, which is widely used, at least until now. Then there is JAX, which on top of JAX, different framework, different libraries like Flax and Haiku are made. These, all these things, Keras, whether it be Keras, TensorFlow, PyTorch, JAX, or anything, even Julia. Nowadays, people are working with Julia to build some models. Whatever these models be, they are very complicated, not extremely complicated, but they are complicated models that people are building using either one of these Keras, TensorFlow, PyTorch, or JAX. So now, as an engineer, as if you are building something for some use case, whatever we build it for a purpose and a reason, right? So whenever whatever you are building, there must be a reason. A reason comes from a problem statement, and when there is a problem, we need solution. So we always try to solve some problem instead of building something. We can build anything, but we should build something that actually works and actually solves a problem. When these things are when it comes to technology stack, you will not be restricted to JAX or Flags or Keras or anything. Uh, by just making sure that you use abstractions. Abstractions like in object-oriented. The speaker only speak, not explain to us. Yes, yes, I'm coming. I'm coming to that. I'm coming to the hands-on session. So what I mean is, we have there are different ways that you can build stuff. But recently, Hugging Face released Transformers project and many example notebooks which help you build many great stuff. So here, one of those, I'll be showing you one of those notebooks where you can build a classification model easily. Let me now show you the notebook that I am talking about. Okay. So you just need to open this link. This link is shared with everyone. Here we will be building a model for classifying images. These images are satellite imagery. Now just go to the first. I hope everybody can run it, but before running, just change the runtime type to GPU. Make sure it is GPU. It is GPU. Now here, a quick check you can do is make sure that the link is coming from a GitHub Hugging Face. So it is coming from GitHub Hugging Face notebooks, and the link and the location is in examples image classification.ipynb. Here you can see a simple notebook for image classification. Same notebooks can be found in GitHub Hugging Face notebooks. The same link that I showed, the repo image that I showed in the previous, okay. Let me just copy it and paste it here. Done. It's going to panelists. I guess someone from panelists can share this notebook, share this link to everybody in the chat. So what is image classification? Very simple, extremely simple. When somebody shows you some picture, you should be able to tell what kind of image it is. That is image classification. Somebody shows you an image of cat, you should be the model should be able to tell that it is a cat. Somebody shows the model image of a dog, and the model should be able to tell that it is a dog. Somebody shows model my image, and the model should be able to tell that I am the person inside the image. That is how they were materials links were shared beforehand. I hope panelists share them with you. Cool, great. So here we will be building a model that can detect different types of satellite images. Here you don't now when somebody tells you how to build this in Keras or TensorFlow or PyTorch or JAX or anything, they will start with the image pixels and all those nitty-gritty details, small details that you should worry about. But using an abstracted project like a transformers, there are two very important projects in machine learning. One is Hugging Face transformers, and another one is fast.ai's fast AI library. So these two do a very good job at abstracting the nitty-gritty, the useless, to be frank, useless steps, redundant steps that one has to follow. Here, just look at what I'm doing. I only need to decide what kind of model I will be using, and this line Microsoft Flash, this comes from a hub where there are many models available. 1 minute, let me just share it again. So this is a model that comes from a hub. You just have to go to hub and check. There is something called Hugging Face Hub, and you can get this model for you. And there is something called batch size. Batch size is very common term in machine learning. Everybody must know it. So here, and it depends on GPU. So here you can just set it to 32.
Excuse me, sir.
Yes.
Your notebook is not visible. Only the presentation is visible.
Okay, 1 minute. What about now?
Yes, sir. Now it is visible.
Okay. So here in the notebook, let's only see the code, not the descriptions. You can read the descriptions later. Everything is explained very much clearly in the notebook itself, but I will show you how to run this. It's simple. I will keep it very short and sweet so that everybody can ask me more questions later instead of just following through the notebook that somebody else has written. Here you give name of the model, There are multiple models available at Hub. You just have to go to Hub and you can see this one is built by Microsoft. Same way you can find a VIT model built by
Sir,
Google.
sorry, sir, again. The screen is stuck and we can only see the data page. Cannot see your notebook.
Okay, okay, 1 minute. 1 minute. I think I found out the issue. What about now?
Yes, sir.
Okay, so batch size 32. Here, if we see, we get a very good GPU. So because we have very good GPU, we can go ahead with 32. Otherwise, we keep it small. Then we install two important packages: transformers and datasets. Transformers are the library that will help us build models and also download models if necessary. Datasets is a library that will help us create dataset objects from raw images. Now, this logging in, you can skip. You don't need to do that. But Git LFS, you have to create you have to run Git LFS because these models and data sets or whatever the large files, whatever we have, it is stored using Git LFS. So just run it, and then let's start from here. Here we are downloading from eurosat.zip. If I go and check eurosat.zip, it has different folders for classes. At first level, there will be a folder, and then inside that folder, there will be multiple folder names. And for every folder name will be a different class. For example, it can be forest, and then hilly region, and then river, and then inside that there will be images corresponding to those classes. Once we have one file like that, you can download this and check and see how the folder structure looks. It creates a dataset object. It is now, if, for example, if somebody asks you to, and it does not only work with zip, you can use any extensions and you can give that file structure here. Now here, this is for Eurosat. These are satellite images from Europe. Now, if you want to do dog or cat, you just have to create a folder structure exactly like this, and then you will be able to build your own model. That's as easy as it is. Now, there are more than one way to do this. You can give a local, using this line of code, you can give part to the folder. This one takes a zip file, but this one takes the folder itself. For example, if this was not, if the Eurosat image was not compressed, you could give directly the uncompressed part to the image. Once you have it, you just run this one. Let's run this one here. So once it says, so there are different ways here. It's option 3, option 2, option 1. They are showing multiple options in which we can download. We can create dataset object. The main purpose here is to create this dataset object which we will use. Now, how do we, behind this dataset object, we use Apache Arrow. Apache Arrow is a very interesting tool that we use behind the scenes. It now to see, I cannot explain in this video how Apache Arrow works, but I can show you what we can do with it. But before that, let's just load a metric called accuracy. And in this metric variable, we are loading a metric called accuracy, it's simple accuracy metric, simple formula for metric. For example, if you have 10 classes, then if you have 2 classes accuracy, it is just simple accuracy formula, that's it. Nothing special. But coming to data set, if you run it, you will see that data set has 2 features, image and label. So it created these two features just by parsing the folder structure. it parsed the folder structure of eurosat.zip, and it created 27,000 rows. So every row is an image and label. So like that, there are 27,000 images, and for every 27,000 images, there are 27,000 labels. Now, if you want to access it, here at index 10, we are accessing a image. An example is the image and label features. Image and label. Now here you can see, if you access an example and just print it out, it shows that image is of PIL. PIL is a library in Python for images. So it actually stores it and even tells you what kind of channels it has, what is its size. And we are storing it at some memory location, which we will come back to later. And labels, we are not storing labels as text. Here it is numbers, but you can get the text here by using the features attribute. Just call the features attribute, and you can see that there are total image. In image, we have image type PIL object, and in label, we have different label class labels. Total 10. There are 10 different types of classes, 10 different types of satellite images. One is annual crop, and one is forest, one is herbaceous vegetation, one is highway, one is industrial, one is pasture, tree permanent crop, like that. We have these many terms. So this is label 2. At 10th index, we 10 out of this 27,000 rows, at 10th row, we have label 2. Label 2 would be forest. So if you want to see that example, you just need to call the image, and the Jupyter notebook will display it for you. If you want, this is a PIL image, so you can call any function that works on PIL image. So resize function will resize it for you. You can just do any other size. But here, if you notice, we are using 224. So here, these are parameters based on which this model is built. It has 4 patches, and its window is 7, and image size is 224. So it takes image. It's not exactly like 224 image, but it will come to that. Will come to that. So we have image data set. This example comes from dataset. Same way, the dataset has different features for train and test. Here in this is very important section where we convert. We create 2 important labels: ID to label and label to ID. Label to ID and ID to label is a dictionary that converts numeric data types to the textual string. These two but we created
Excuse me, sir.
here first. Simple, just yes.
Yeah, so your voice is breaking again.
Okay. What about now?
It's a little better, but
One minute, let me check. Let me check. Hello, hello, am I audible now? And what about my screen? Can you see my screen?
No, sir.
One moment. Now you can see my screen,
Yes,
right?
yes, sir.
So here we are just creating ID2 label and label2 ID variables that map IDs to labels, and then we load. Here there is an important abstraction called auto feature extraction, and this hides everything. Like someone asked, is it about math? It's not about math, it's about magic. Magic is something that you don't need to understand, but you see it working. That is what I would call magic. And you just need to call this feature extractor, and it will create a variable called feature extractor for you. And this is what the feature extractor does for us. It's a VIT feature extractor which does normalization. Normalization is very common term in machine learning, and it does the resizing, and it changes it it uses this mean and this standard deviation numbers to do the normalization process. And it also does the resampling and resizing to 224, the same number that I showed above. Now, other than that, we can, if required, we can add different kinds of augmentations here. And these augmentations come from different, you can use different frameworks to do the augmentations. You can use albuminations, cornea, image of, or anything. But here in this, we use native PyTorch augmentations. Once you do it, you create two important uh, functions called pre-processing. And this pre-processing is what returns an example batch. This batch is what goes into our model. Now, once we have our data set, we divide the data set using train and test. So by using 10%, so 10% of 27,000 is 270. So 270 goes in 270 example goes into validation, and then the remaining goes into train data set. Then we call the pre-process, these two pre-process functions that create these batches for us. And this is very important, set transform. Once we do that, this is the same Apache Arrow data set. And then we are actually setting the pre-process, setting some functions. So those functions will work on it on demand. It will not work right now, but it will work when needed. That is what makes this software that is what makes it faster, in short. Now, for example, now if you ask for train DS0, it shows image, label, and pixel values. Pixel values come from here. This was added additionally. Now these pixel values are what goes into our model. It is of type tensor. That's it. That's whatever I told you, that is all you have to do and to do the training. Here everything will remain same. The only thing that you need to change is your data set. Once you change your data set, it's more like data centric. It's not like data centric machine learning where you change the algorithms again and again, but it's more like model centric machine learning where model remains same, but you change the data set as you need, making sure that your model accuracy increases. Then here also we have another abstraction. I I use magic for abstraction because you don't need to know anything about the model, but you just call auto model for image classification from pre-trained, and it loads the pre-trained model for you directly. Once you have it, you just give the training arguments like the learning rate and save strategy, epoch. You can either do it epoch wise or stepwise, and then you can then warm up ratio and then logging stats, then load best model at the end, true, all that, and then the metric for best model accuracy, like that. Here you can just change it to false because you have not logged in. If you have logged in, you need not change it to false. Once you change it to false, now you can run it. And once you run it, you can see here the trainer. The trainer is the one which takes the args that you created. You created some args here, right? So these training arguments is again taken in by a trainer class. Here everything is object oriented. That's why at the beginning, that's why it was mentioned that a software engineer can do machine learning now because it's everything is well documented and everything is config based. Here you just need to understand why, what args you need to change, what numbers you need to change. Other than that, all the steps will remain same. Then you just take it and run it. Once you run it, you will get losses decreasing and then accuracy increasing. Then once you get something like that, you can save your checkpoints, and then once you save your checkpoints, you can even push to hub. You can, so here interface gives you so much space that you can push your hundreds of MBs model to hub and keep it there forever without even charging anything from you. So you can do that. For example, here this guy shows how we can save his model. Once that is done, inference is very much simple. Inference is very simple. You just need to call torch with torch.nodat. You have to call more, you have to send a dictionary inside model called encodings. And this dictionary will output logics, and the maximum of the logic score. This goes to softmax, right? So softmax, the maximum of softmax is our answer, the predicted class. For example, here this was forest. This image, when sent into our model, it detected it as forest, which is correct. And there are many other things that you can do. You can go through the notebook and read it and understand it, and make sure that you try. Everything is explained very much clearly. So I need not explain the pipeline API and everything. These are only same things which can be done differently. That is what you could say polymorphism is. You can do same thing multiple ways, but it should be very strict, and when everything is well documented, everything becomes easier. So transformers documentation is what you should look at when you do everything. So once you understand the documentation, everything will be easy for you. So that's it. That's one hands-on session for you. Anything else you can let me read through chat for now, or can now if I can take questions now. That's it from my side. Am I audible?
Yes, sir.
Was I audible? Yes.
So there are two questions in the Q&A section.
Okay. Yes.
Someone is
Okay.
asking.
How does the data label know which image belongs to what label? So here you just have to create a, I will just 1 minute. You just let me, you create a, here you will be having main directory, and inside main directory you can put one folder called test, and inside that again you can put another folder called train, and then inside train you can put another folder called dog. And here inside dog, you can have image of dog1, im1.jpg. Same way, here you can have another image, im2 of jpg. Same way, if you have many images, they will follow the same path. Next, you have another class. Let's say you have cat. Then you put cat, and then same way you put im1.jpg that belongs to this. You get the idea, right? So inside train, there will be different classes, and for every class, you will get different images. So that is how the dataset lab knows by structure. So there is a definite structure that you need to follow. And once you follow the structure, the dataset library will know it. Then what is warm-up ratio? Warm-up ratio is something, there are some steps for which the training does not happen as we expect it to happen. So that warm-up ratio is, it's more complicated than that, but in papers it is mentioned that when you use warm-up ratios, it's better. The training accuracies are better. How will we evaluate the performance of model for image recognition? We can use many, it depends whether it is imbalanced data set or not. Many factors depend on it. For a very simple answer would be accuracy. You could use accuracy or cross entropy or anything. When you were passing hours, why haven't you utilized TensorBoard for getting details regarding? We can do it. We can use TensorBoard. If you don't like TensorBoard, Hugging Face also supports weights and biases. You can use it. You can use anything. It does not matter. But if you want to use it, you use it. If you don't want to use it, you don't use it. That's completely up to the user. That's it. Any other questions? I see 55 participants here. Does anybody else have a question, or can we wind up the session?
Okay, guys, I think anyone is having questions, then I think all the questions have been answered.
Everything is answered. Yes.
Okay. Okay, so am I audible?
Yes, you are audible. Clear.
All right. So thank you so much for joining us today. And thank you so much, sir. On behalf of Analytics Vidya, I would like to thank you for your time and for delivering such a wonderful session. I'm sure our audience found it insightful, and hopefully we can conduct more such sessions with you in the future. I've also shared all the links, the LinkedIn profile and etc.